when we look at equipment size, especially in the U.S., and if we also consider Europe, what we're seeing is we're bumping up against limitations in being able to transport. And there's two types of transport. There's from the farm to the field, and we're talking about local, but we're also talking about transporting from the factory to the farm when the equipment's sold. And so there's some issues coming down the road. 600 horse four-wheel drives, we're getting to the point where it's a couple loads to ship it from the factory to the farm or the implement dealer. More importantly, when we begin looking at implement widths and things like that, and when we think about on-highway safety, there's an issue that's of concern there too. So both things are kind of working against producers in terms of going to larger sizes. Obviously, when you look at the Europeans, they already have the 3 and 3.5 meter width limitations on transport of current equipment, which is forcing them to be very creative when they go to the higher horsepower tractors. The one thing we're seeing today is a lot of automation on field machinery, but it's also on big iron. And when you think about that, there's a liability issue that is going to keep us from removing the operator from the equipment with the current size of the equipment. What we're looking at interim is maybe one operator supervising many pieces of equipment in the field. In terms of total autonomous operation, I think that's a few years off yet, and probably one of the things we're going to see when we do get to fully autonomous equipment is a reduction in size. We're probably going to see going from the 500-600 horse down to something much smaller because we'll be able to do that in some respects. There's going to be some other things, I think, in the future that drive equipment size, and one of those issues is going to be the realization of the sacrifices that we've been making in terms of yield because of compaction. Even minor reductions in soil compaction, we're going to have profound influence on the overall economics of autonomous equipment. And what I'm suggesting is by going to smaller equipment, we're going to, even modest yield gains will be pretty substantial in terms of the money that it frees up to put into totally autonomous vehicles. There's one other issue too, and that is when we look at the hardware being produced today, the life of that equipment probably somewhere in the 15 to 20,000 hour range. And if you look at the average Midwestern farmer, they're typically using that equipment about 500 hours a year, meaning most of the tractors sold today are going to be on farms between 30 to 40 years out. One of the things I also see happening perhaps is a reduction in the life of some of the hardware being produced. And specifically what we're going to see is technical obsolescence and machine life coincide more than perhaps they are currently or currently today. Yeah, one of the things we'd like to go down that road at Ohio State in terms of some of the control architectures, specifically as it applies to fleets of autonomous vehicles. And while we see a lot of things happening right now in the field, there's also going to be some attendant or some additional sensing technologies and some intelligence that we're going to have to impart to that equipment so it stays in the field. The biggest thing when we look at planning, spraying operations, anything that requires input is the refill interval and how that's going to be accomplished. And then we also have to make certain that the product's getting in the furrow and there aren't any malfunctions of that equipment in the field. So some interesting opportunities going forward in terms of what universities might be doing for research.